Page 509, indirect measurements. You're going to need a highlighter and a pen. We're talking about indirect measurement where we don't have the ability to measure the actual object, but we can use similar triangles that have been created to come up with a way to measure using proportions and get a good indication of how big that faraway object is. We need to know a couple of things. First of all, it's going to be based upon, in this first example, mirrors. And when you stare into a mirror directly into it, you're getting a 90-degree bounce back from the mirror, from the light that your eye is, catching and absorbing and reflecting, and the mirror is bouncing it back to you. So when you look into a mirror and you see yourself, that's because the angle of incidence between you and the mirror and the angle of reflection is exactly the same, or maybe even like zero. You're lined up perpendicular to it. But if you use a mirror to see around a corner or to see like something above you or whatnot, then the angle that your eye is making to that mirror and then from that mirror to the other object, like behind you or around, they're not the same. They're not perpendicular, I should say, to the mirror surface. But they do happen to be the same measurement. So angle of incidence is maybe like the light bouncing into the mirror, and then the angle of reflection is like that light bouncing back to your eye. And so we're going to be using the fact that those angles are congruent to come up with similar triangles. And then as we're coming up with similar triangles, we're then also going to be looking at the proportions that can be created. Right now I'm going to add, maybe I'm going to use blue instead of red, because I notice there's a red line right here and a green line right there. Sorry if you're colorblind. And I'm going to put that, if there's a one spike like arc on the angle of incidence, there is a double spike on the other side. And those happen to be complementary, which means they add up to 90. And for maybe the same reason, maybe the tilt of it, I'm going to be very cautious here. I'm going to say there's something about like that line. I'm going to put 3 there. I don't think they quite equal. Maybe they do. Maybe they do equal because of like the way that it like bounces in relative to the center. This has to be 2 spikes as well. So if this one spike formed with the perpendicular angle here has a complementary angle, and this one spiked angle is the same as that one, then by equivalent complements, there's some sort of like theorem there, these 2 angles on the sides, they have to be equal. They have to be similar, or no, equal in angle and similar in triangle. So we have some other information in the paragraph to highlight. We're going to talk about indirect measurement, and we're going to be using the angle of incidence and the angle of reflection, aka the law of reflection states that the measure of the angle of incidence equals the measure of angle reflection. It is kind of like when you are driving in a car. Remember this when you take your driving test. If you can't see the truck's mirrors in front of you, the truck driver can't see you, because what you see bouncing into the truck driver's eyes is reflected in the same way back to your eyes. So be safe out there, drive safely, and know that when you are messing around on the road with big rigs, if the guy can't see you, the truck driver can't see you, if you can't see him, he can't see you. They can't see you. Okay, so let's use these steps in order to apply this problem to solve indirect measurement problems. And in fact, I've done this in one of the short videos. So I'm going to share with you just like it is there. If you want to see an example of me being that guy and our school's flagpole being the flagpole like in the picture, well, it's like this. And no sound, just to kind of play it for a minute here. Oh, this is me. And I'm outside and I'm measuring the flagpole, and you can do the same. And it does end up establishing proportions. What an amazing, informative video. Thank you so much for watching that with me. However, if you want to know more about it, you want to see that, go watch those 1-minute videos. I'm going to dive in and just say this is what we're really setting up here. You should absolutely draw the diagram of the person, the flagpole, the mirror. You're going to use a marker to locate this distance. You're going to use the spacing. You're going to set the mirror up spaced so that from where you stand, you can see the top of the flagpole. And need a straight edge here. So you're going to end up creating similar triangles when you draw line of sight to the mirror and then because light bounces according to the law of reflection. That light bounce up to here is going to create a small triangle because, we're from 0 to 7 feet tall. And then over here, this larger triangle is created because the flagpole is from 0 to 50 feet tall. So this triangle will be bigger, but because of angle-angle similarity, the angle here and the angle here are equal. And unless you're like leaning over, this should be a right angle, just like the flagpole should be creating a right angle. Therefore, we have two similar triangles because there are two corresponding and congruent angles within those two triangles. Now, you ask your partner to sketch a picture of you, the mirror, and the object. And then step 5, you're going to review the sketch. You're going to decide where to place the right angles and where to locate the sides of the two triangles. So with the little highlight action, I just want to encourage you to understand that the flagpole's height and your height are similar or corresponding sides of the proportion. The distance the flagpole is to the mirror will be proportionally equivalent to your distance to the mirror. And although we never really need to measure this in this specific example, we're usually trying to check the height of the flagpole, because what are you going to do? Leg the flagpole over and then measure it while it's laying on the ground? Good luck putting it back up. That doesn't sound very smart. But if we needed to, you could also say this line from the top of the flagpole down to the mirror is going to be corresponding and therefore proportional to your line from the top of your eyesight down to the mirror. It shouldn't be the top of the head, by the way, right? Your eyes are not located up here, and therefore this distance could be enough to translate to like feet off in the final amount. So when you go do this for yourself, which maybe in my class we've gone outside and done this already or are about to, you need to measure from height where your eye receiving that information, that light information is. And my eye height is about 6 feet off the ground, maybe a little less, maybe about 5'10". Okay, all right. Big forehead time. Okay, so what you're going to do, you're going to go ahead and practice this in some skills. On the next page, I'm going to answer these questions 2 through 6. But that concludes our conversation for page 509. Please go watch that short video. Stick around for page 510, and I'll see you in the next episode.